Part 2 focuses on the modeling process and something that you'll get used to seeing, the initials RBP, which stands for Reference Behavior Pattern. The first major step in the system dynamics modeling process is to define, articulate, clarify the issue or problem. Basically, focusing the effort. Why are we doing this? What are we trying to accomplish? And it's important to be as explicit as possible about the purpose, because modeling tends to explode if you're not really clear on the goals. So that means having a very specific question or small list of questions that you're striving to answer. And those questions shouldn't be just general questions like, how can I make the system improve performance better? But rather, very specifically, questions like, what would the impact be if we changed the fishing limit from 0.4 MSE to 0.3 MSE? So a very explicit purpose. The second thing we want to clarify in the early stages, what is the reference behavior pattern? And we use pattern to take emphasis off of the exact numbers, but we are looking at behavior over time. So what is it about the behavior over time? If we're in an organization, are we looking at profits and they're eroding downwards? They were going fine and then they turned and went the wrong way. Our sales were going up and now they've leveled off. Or if we're looking at the general economy, we look at exports are becoming less, or whatever. So that's really important, and that's one of the things we try to accomplish in the first phase of the modeling process. And then at that stage, we also are probably sketching out a very preliminary version of the model diagram to sort of kind of outline the boundaries that we're working with and what some of the major components are. Phase 2, the second major stage, this is my sort of synthesis. Some others use a 5-stage process where they talk about expressing the dynamic behavior at around this stage. But I put that in with formulating the model. So you'll see here that developing and representing a dynamic hypothesis, kind of what is your kind of deep overall theory for what's going on? Is your capacity being tapped out and you haven't been able to replenish it? Do you have if you were starting a brand new company, maybe you had a highly motivated initial group of people, but it's hard to find people who share the passion for the industry, or in a nonprofit the same kind of a thing might be true. So we're trying to come up with an organizing principle, a kind of a fundamental idea about what might be going on that's going to kind of guide the effort, and then map out kind of what our hypothesis. So sort of talk causally from step A to B to C. What do we think what is our hypothesis about what is going on in the system? And then the other step is to actually move into what we describe as thinking operationally. And Barry Richmond, who I borrowed a lot of these ideas from, he says make the map, this sort of diagram, simulatable. Identify the storages, the places, the state variables of the system where the accumulations occur. Characterize the flows that come into those stocks or state variables and out of them, maybe at the boundaries of the system as well. Then once you've kind of mapped out the system, begin identifying the feedback loops and talking about how they might work. And then finally, specification and calibration, determining what the actual equations are. Most of that focus is on the flows or the rates of change of the variables and what the parameters are that actually determine the numerical properties of the system. The third major stage of the overall process is to test the model. And that includes some early stages that people think of kind of more or less being associated with debugging, kind of getting the model to working right, eliminating sort of mechanical mistakes, just typos, things like that. And then to begin doing some robustness tests, just to make sure that by robustness we mean if you change the way the model is specified, or in particular if you change parameters by small amounts, is the system highly sensitive to that? That would kind of indicate a basic formulation problem. And then very often in the early runs that you make, you get kind of surprising, bizarre, unexpected behavior that doesn't seem right. And so you're trying to figure that out, say, well, what have I done here that doesn't match with my actual conceptual models? We're trying to look for problems in just how we implemented it in somewhat of a mechanical way. And then the next stage is verification, where we're really carefully comparing the implemented model to our kind of conceptual model that's in our mental models of how things work. And to do that, I recommend that you really focus on understanding how your model works, what its dynamic behaviors are, which means exercising the model thoroughly. Some of that's just kind of mechanical. Go into each parameter and move it around and see what happens and make runs. And keep a good logbook of everything that you're doing and say, is all this making sense, or am I starting to uncover something that doesn't feel right about the model? And in the verification stage, we're really mostly comparing the model to what we thought should happen, and we're not really going out to the real world yet. We can conduct hypothesis tests like, well, if we make this kind of a change, obviously this sort of a thing should happen in the model. And then I mentioned earlier exploring the dynamic behavior thoroughly. So really, in some ways, if it took you a dozen hours to build the model, you should spend at least a dozen hours experimenting with it to really figure out all the nooks and crannies of it, of what it might, how it might behave. And in that process, you're going to find lots of warts and flaws that need to be fixed. And as those warts and flaws start to not be popping up, then you might start shifting towards the validation phase, where first and most importantly, you're trying to replicate that reference behavior data that you established up front during the first phase of the process. And then challenging the boundaries, making sure over what range of possible conditions does your little model work. It's not going to work broadly. It's going to have a fairly narrow range of applicability. You designed it that way, and you were able to build the model quickly as a result of those decisions. And then the final stage of the overall modeling process, to actually use the model to answer the questions that you set out to answer, and then transferring that information so that others besides you and those people closely associated with the modeling project will actually see that there's some credibility of what you've done and actually might influence decision makers, policies, etc. So in that process, we design and evaluate policies. Some of those policies need to be sort of theoretically motivated based on what prior researchers and practitioners have been doing. We also need to study the sensitivity of the policies to changes or possible uncertainty in the parameters of the model, so that we can say these policies are robust with respect to the things we're not really sure about in our model. That's not easy, but it's really, really important. And it's very often useful to be in a position to to study specific scenarios of interest to the client or to your own organization if you're doing it on behalf of your own organization. And then I love, this is straight from Barry Richmond. He was really focused on learning. Make learning available. So communicate what you've done in very compelling ways. These are his words. Develop a drama. Get your model to tell a story in a really exciting way, or do that storytelling yourself using the model. He also, in the tool that he designed, which was Stella, which is not the one that we use, they have some special features in order to sort of what he called unfurl the logic of the model slowly, one step at a time, so that consumers of the model could think about that and absorb the logic of the model. It's really useful. We can sort of do the same thing in terms of how we present and describe a model step by step. But he made special tools available for doing that. He also used the words create in-character feedback. In other words, imagine that that the way the model works is that it gives you insights. How are you going to express those insights? And how could you coach or encourage somebody to change the way they think about things based on the model? That's getting pretty deep and going kind of beyond what we normally think of as analysts. Well, we just build the model, we test it, we make the runs that the client wants, and we hand it to them, and they figure it all out. No, Barry would say, and I would agree, we have to go beyond that, to actually thinking seriously about how do we transfer what we've learned so that there's actually impact from this process that we've undertaken. So to provide just a little bit more information about the reference behavior pattern, it's the actual behavior of the real world. Sometimes it's sufficient to describe it qualitatively in a prose description. Well, the system has grown to its capacity and seems to be sort of unable to move any further in terms of towards more sales or more profit or more productivity of a fishing situation in an ecosystem, fisheries. So, or more ideally, it's described quantitatively in either tabular or graphical format. I prefer graphical format, but tabular format can be useful for inputting the data so that we can do very explicit graphical comparisons between the model behavior and the reference behavior data that we collected. Usually we start with just one or two key measurable aspects of the real world, some of the words that I've been describing, like profit or sales in the business environment, or fishing success in a fisheries or something like that. Ideally, these kind of encapsulate the key behavior. Very often I recommend that we try to come up with at least two measures, both of which are not so highly correlated. They're sort of orthogonal measures, so that doing well on both of them is pretty challenging and represents higher confidence that we're actually moving the system in the direction that we want. And then we document the key aspects of these particular key aspects over time. An example I mentioned earlier in a slidecast was exports. If we're worried about sort of so-called offshoring of manufacturing in the United States to other countries, which was actively being done, what's the actual data on that? How much manufacturing was actually offshored, and has it been increasing or has it been steady? Those things matter a lot. And in the end, those graphs and those prose descriptions should capture the essential qualitative behavior as well as the quantitative behavior. Are we really talking fundamentally about growth or oscillation or stagnation, overshoot and collapse, in a bad case, etc. This sounds kind of funny, but I say place that information in a folder, electronically or physically, call it reference behavior pattern. And the reason for labeling it and kind of cloistering it that way is so that you know that when you look at that data, you're looking at your reference data. That's fundamentally going to be used to validate your model. And if you use it extensively in the building of your model, you're sort of tainting its utility as a cross-check on your model. I mean, if you very carefully made sure your model does exactly what your reference behavior, as you go, tells you, then that's not really an independent test any longer. So while we will all be sort of aware of the reference behavior that's driving the motivation for our study, we don't want to be constantly looking at the specific numbers and trying to make our model produce those. Or at least, and here's another strategy, you might set aside part of your data to be very carefully used as reference behavior, and then allow yourself to look at some of the data intensively as you build the model. Sometimes that would be the most recent 2 or 3 years you'll sort of blind yourself to and use the older data to get the model working. So it's important that this data, the reference behavior, is developed before the models are created, or at the very least before we're starting to make simulation runs and twiddling with our model. To summarize, reference behavior is used in a sort of indirect, careful fashion during the modeling construction to help guide the effort. We don't want to be focused too sharply on the numbers in this process, but more kind of the general background of what that reference behavior is telling us. It's also used during model verification as we start testing the model to see if the model of behavior is kind of approximately correct, and then it's explicitly used during model validation when we start to compare the model behavior more formally to the reference data. We'll talk a lot more about this later in the course.